And welcome to the Daily Space Weather. It's still a filamentary fest, and we do have another new large sunspot group just rose in the east. So that's what's going on. Let's take a closer look. A lot closer look. This is the last 24 hours from the SDO, the Solar Dynamics Observatory in 304 angstroms, which is ionized helium. So we've got filaments, a really dense one here moving toward the western limb. We've got some active regions setting up here. That increases their likelihood of producing solar flares. We have a crown prominence up here near our Earth scale. Let's take a little closer look at that. Also, you'll see a prominence popping off there around the west. Here's a close-up of those filaments that are encircling the northern polar region. What's that? It's not close enough for you? Okay. That should provide sufficient detail, wouldn't you say? And let's do an equatorial zoom here. By the way, for everybody who was hoping the sun would shut down so they'd be correct or something, or because they're very worried that a grand solar minimum is going to cause the end of civilization, snap into reality. Snap into reality. Look at the filaments. Massive number of filaments here on the Earth-facing portion of the solar disk. Let's briefly take a look at the southern polar region. But first... oh, there is no but first. We're already on the southern polar region. By the way, once again here, above the Earth scale there are a series of quite large and quite dense plasma filaments, so the likelihood of coronal mass ejections in the next 24 hours is nearly 100%. So here are these two new active regions. The one above the Earth scale is already named. The one below the Earth scale there doesn't have a name yet. By the way, I think that is now the most likely place to see a large solar flare. We are seeing a little uptick here in the X-ray flux and a little uptick in the radio flux. So that said, let's move on and take a look at sunspots here. There is the past 24, that's yesterday plus today. So it's actually more than 24 hours. It's all day yesterday, August 21st, and today to date. Right at the end of the video, you'll see a little dark region popping up right over here. That is that new sunspot. It's decent size, similar in size to the one to its north. Here's a colorized magnetogram for that same period of time. And let's blast through what's blasting off on Croissant Earth. We want to know what volcanoes are erupting, so we report it. It's a popular crowd favorite. So Abico is producing a 15,000-foot ash plume over Paramushir Island. It's a flight level 150. Flight level 070 over the Ryukyu Islands from Subanosejima. 7,000-foot ash plume. Unknown volcanic ash plume from Mount Mayan. Please do not assume it's not erupting and decide to pole vault the caldera. Keep your field events away from the volcanic calderae. Revenador in Ecuador is exploding, producing a 14,000-foot ash plume. It's a flight level 140. Flight level 240 over Sabancaya in Peru as it explodes. It's produced a 24,000-foot ash plume. Flight level 200 over Ubinas in Peru as it explodes. It's a 20,000-foot ash plume. And let's move to seismicity. Getting into a little bit of a 7 magnitude earthquake drought here. Seismic activity has been low for the past 24 hours. And only one 5+ magnitude quake has occurred in the last 24 hours. It's this 5.2 at Indonesia. I would also note that it is at extreme depth, over 500 kilometers estimated depth. That would be a mid-magnitude 6 earthquake had it happened at the surface. So just scrolling up the list here, let us know if we've missed anything. It looks like a few Texan quakes happening there. However, since they are smaller than a 5 magnitude, we will not call them out specifically. Anyway, there's the list. If there's anything we've missed, drop us a line in the comments and let us know. So there you go. There's the past 24 hours. And fun fact, I swear I've been feeling earthquakes here in Pennsylvania. So that's a really strange thing. The last few days I felt one around 1:29 Universal Time. Yesterday it was pretty weird. I actually reported it to the USGS. I don't see it on any list though. So anyway, let's switch over here to our 171 angstroms wavelength. There is the last 24 hours from SDO once again. And I would definitely say that the most likely place to see large solar flares at the moment is right around the eastern equatorial region, right in there. And of course you can see some activity happening there indeed. Here's a slightly closer look. So there will be at least one new named sunspot group today. It is similar in size to the one north of it. So we'll show you high-res imagery of that before we get to our bonus features segment. Actually, before we get to our meteorology segment. And let's take a look at some stats. The 10.7 centimeter radio flux is now at 149 solar flux units. It comes out of the upper chromosphere and lower corona, right around here. The transition region. The sun's lower atmosphere. The chromosphere. It's almost like Earth's troposphere. Anyway, here's the 1 year graph of the radio flux. It's that black line. 149 is the current 10.7 centimeter radio flux. And here is the Space Weather Enthusiast dashboard. NOAA not forecasting any geomagnetic storms or geomagnetic unrest. We have had a ramping down of the solar wind. We'll talk about that momentarily. First, let's take a look at Croissant Earth and its magnetic moment from space. Here are the past 4 hours depicting magnetohydrodynamic pressure. And we see most of the pressure here in the magneto tail side, an indication that solar wind speed has recently depleted, and now it's come back up again. That is because of changing of the instrument. Keep in mind that is a model, folks. Next is the ground magnetic perturbations map, also based on the space weather modeling framework. Also the past 4 hours, this depicts magnetic flux density in nanotesla at Earth's surface. It'll show you the most likely places to see. The aurora, pipeline, railway, and power grid induction. Those are telluric currents and their likely locations on our ground magnetic perturbations map. Planetary K-index currently at 2.66. And let's move to the real-time solar wind next. Keep in mind that it is measured at Lagrangian point 1. We like to show that diagram there, that animation courtesy of Wikipedia. The ACE and Discover spacecraft are orbiting that gravitational equilibrium point shown there as L1. It's Lagrangian point 1, folks. The location where the real-time solar wind is measured. So there has been an instrument switch indicating higher density plasma at the location of the Discover versus the ACE. However, similar plasma speed, also hotter plasma there at the Discover versus the ACE. We can tell based on that bottom line there, it turns from green to blue. That's the switch over from the ACE to the Discover, and that's what also shows that increase in magnetohydrodynamic pressure. The Geospace Magnetosphere movie shows the active spacecraft. So current conditions are, as measured by the Discover, about 8.5 protons per cubic centimeter. Again, solar wind speed here has most definitely declined quite a bit since yesterday, coming down from about 600 kilometers per second down to about 500 kilometers per second. So still elevated here, still a coronal hole high-speed type wind stream. And let's move to the GOES magnetometers. So seeing some little sawtooth variations happening here in the past few hours there. Around midnight local time for the GOES 16, which is represented by that red M there. Noon local time for the GOES 16 is represented by the red N. And next, let's move to one of the most important features of the daily space weather videos, the top view ecliptic plane field plot. So Earth has snapped into a south pole current sheet, It was happening right around when we made yesterday's video. Here, the South Pole current sheet depicted in red. That is solar plasma, which is polarized to these south polar fields. Here we've got north polar fields up here. Again, Earth just left the North Pole current sheet. And we can expect the South Pole current sheet here to persist for a day or two. Let's take a look at our line of sight field plot next. Here the sun's B field is depicted in blue. This is the torus that everybody's always talking about. The torus. It's not donut shaped at all as we approach solar maximum. By the way, we're like a year out from solar maximum yet. So if you think you've seen the peak of solar activity for solar cycle 25, think again. You can expect nearly 2 more years of activity at this level or higher. So again, about a year out from solar maximum here at the moment. And the sun's B field is a little chaotic looking as a result of that, which is what happens during a solar cycle. Let's move to coronal holes next. They're the main feature besides sunspots for solar cycles. They are the source of the high-speed coronal hole winds, or at least their walls are the source of the high-speed solar winds. We won't get into that too much, but there is the coronal hole line of sight plot. So we've got both north and south pole oriented coronal holes here on the Earth-facing portion of the solar disk. Let's take a look at those from the SDO 211 angstroms wavelength. So there are the past 24 hours in 211. And again, we do have north and south pole oriented coronal holes there. If we bring up the latest image, there you can see quite a bit of red and quite a bit of green. So there's the forecast for increased coronal hole coverage coming true, and you can expect that to continue for like 2 years, because we're still a long way from solar maximum. I know people have been saying we're at solar maximum since January of 2023, and that is because, I don't know why. I guess because they don't believe in reading or understanding anything about heliophysics. They just say stuff because, I don't know, because it sounds spooky. It's pretty pathetic. And yeah, I've got a quote about this kind of stuff. And we'll include this when we talk about solar filaments. So in the meantime, let's move to sunspots. So here's the situation. Again, one new sunspot here. It'll be 3414. It just rose right there. You can see that magnetic field popping up. We already showed it, but we're going to show it a little bit better here. So let's switch to that. Here is the equatorial zoom from SDO. All right, so let's see what we see here. Do we have any major evolution of sunspots? Any new groups popping up? Well, not really. Most of these groups are quite stable over the past, that is about, let's see, that must be about 20 hours, 21 hours, something like that. And right at the end, you'll see this new sunspot popping up here over the limb, making that eastern limb the most likely place for large solar flares, in my opinion. By the way, we're going to cover cosmic rays today. We haven't done a cosmic ray update for a while, talking about high energy particles from beyond the solar system. But first, solar energetic particles around Earth's magnetosphere. So here is the GOES-16's measurements of the proton flux, and no spikes in that, so no solar energetic particle events. We've seen some very calm activity here, some calm lack of activity here from the closest star. However, little uptick in the X-ray flux happening here. The background X-ray flux back to approaching a C-class background flux level, and the average X-ray output here in the past 24 hours has been like a C2 or something like that. Largest flare in the past 24 hours happened right around midnight. universal time. It was about a C5.76 class solar flare, which we will now show in spectacular detail. So here's the past 24 hours. We're showing 131 plus 94 angstroms. And that largest flare did indeed come from the eastern limb. And you can expect activity to continue there. There is a possibility of M or even X-class flares over there. I think M-class flares are more likely. And remember, folks, there still is a possibility of large solar flares on the western limb. Both in the north and the south, we've got active regions setting, which statistically slightly raises their likelihood to produce solar flares. Next, let's move to a star chart, as I'm interested in what's going on overhead. What about you? And so I like to use skyandtelescope.org's star chart. Saturn's setting over there, which should make David Icke happy. I guess that'll make it less likely for lizard people to transmit spooky, spooky signals to the moon, which transmits spooky, spooky signals to Earth. You've got Jupiter high in the sky here, the brightest star Sirius over there, and Venus here rising just ahead of the Sun, the third brightest object, my favorite planet. Yeah, my favorite planet, including Earth at this point. Anyway, here's your solar system forecast. And yes, I find Venus much more interesting than Mars. I find Mars to be a barren, boring world. And I find Venus to be a rich and interesting chemical soup. So anyway, here's your solar system forecast. That's where things will be in a week. And yes, Mercury retrograde or something is a thing. So yeah, that's something that you can be spooked of. And let's talk about Galaxy Zoo. Yeah, Galaxy Zoo. It's a fun time. The Zooniverse.org. Zooniverse.org, folks. It's the largest citizen science project in the world, and we need people like you to help classify galaxies. So the Galaxy Zoo project, we've been showing it daily here for a while, in lieu of cosmology segments, because we encourage people like you to make accounts over there at Zooniverse and help out with galaxy classification. So let's do it. This one's got features. It is not an edge-on disk. It does not feature a bar, so no bar. Does it have a spiral arm pattern? Well, it looks like it does to me. And it's quite an interesting galaxy there. It's got like spiral arms that are starting well outside of the galactic core area. So we're going to say medium tightness of those spiral arms. And I see, let's see, one. I'm going to say I see only two there, because these aren't really very curved, but these two do look like spiral arms. Now we'll say three. This one looks like a spiral arm too. So we'll say 3 spiral arms there on that galaxy. Does it have a bulge? It does have a bulge. We're going to say moderate. Are there any obvious bright clumps? Well, certainly there are. Does it look disturbed? It doesn't really look disturbed. And let's talk about the other features on this galaxy. Let's see. Does it have lensing? I don't think so. There is some irregularity. There are some dust lanes. There is some overlap happening there. Central diffraction spikes. So that's a good one. An interesting galaxy indeed there. And boom, that galaxy is classified. Will you classify that next galaxy? Well, be my guest. Let's move to the astronomy photo of the day. By Bray Falls and Chester Hall Fernandez. It is the Pistachio Nebula. So this one is actually recently discovered, interestingly enough. And while it's kind of faint, it's actually about the angular size of the full moon. Those colors that you're looking at there are hydrogen and oxygen. And the central star there is believed to possibly be a white dwarf. It hasn't really been studied yet because, again, this is newly discovered nebula. If it is a white dwarf, it'll be believed to be a planetary nebula. So interesting hydrogen filaments out there, and then a bunch of oxygen in the central portion of it, apod.nasa.gov, if you want to check that out yourself. And let's do a cosmic ray report, as we do it at least once a week on the channel. We haven't covered cosmic rays here for a while, so let's do it. Here's your cosmic ray report. Cosmic rays are high-energy particles traveling at nearly the speed of light that come from outside the solar system and indeed outside of the galaxy in some cases. It's very difficult to determine where they come from. There's only one for sure known cosmic ray point source, the star Deneb, the brightest intrinsic object visible from Earth. And if you're in the northern hemisphere, protons from Deneb have been going through your brain. Did you know computers are designed to overcalculate in order to prevent errors that are produced by cosmic ray flux? Anyway, cosmic ray flux is at its lowest level since the year 2004. So if you're worried about cosmic ray flux ending civilization, well, that's not happening either. Again, lowest levels of cosmic ray flux since 2004. Anyway, here's the Apatity neutron monitor. And we have a little downtick there over the past 30 days at Apatity. Next, Barentsburg. A little larger downtick over the past 30 days at Barentsburg. So those are the first two neutron monitors we'll look at. Next, we'll go farther south, way farther south, to Athens, Greece. Athens, Greece here showing a small uptick over the past 30 days. It's slight, but it is a slight uptick. So flat to upward trajectory there at Athens, surprisingly. Next, we'll go much farther south to Mexico City, which shows a small downtick. So flat to down there at Mexico City. And last but not least, we'll show Oulu, DOMC, and DOMB Antarctica. So here's what I'm talking about. Here are the lowest levels since 2004. This is not controversial. These are just basic facts. There it is, 2004. Cosmic rays not at their highest levels ever measured, and they haven't been since all the way back around 2010 or so, 2009, 2010. Oulu's neutron monitor showing a downtick over the past 30 days. DOMB showing a downtick over the past 30 days. And also DOMB Antarctica, a downtick over the past 30 days. So overall, cosmic rays here down slightly, and you can expect them to drop a lot more in the coming days because we are not at solar maximum yet. So I feel like a broken record saying this over and over again. Let's take a look at coronal mass ejections. So we've got an unfortunate dearth of data. We have a shortage of data here. We have some CMEs happening early this morning. Are they earthly directed? Well, we'll get to it. Again, a lot of data missing here on the coronagraphs. However, we do have some. So never fear. Never fear, because the sun's not going to kill you. The sun is your pal. Not a deadly, deadly, spooky, spooky space specter. It's not a spooky, spooky space specter, folks. Now we show this diagram because unfortunately stereo A is right in front of the Earth, so it is not very helpful at telling us trajectory. However, sometimes it does include data that we are unable to see from other coronagraphs because of missing data for whatever reason. So let's move this ahead manually here. So here's yesterday. And really we've been seeing a shortage of CMEs here. So there's yesterday. And there is a CME here showing up around 3 o'clock this morning. I don't think it's earthly directed, but unfortunately, again, we've got a very lack of data here. It looks like there may be some more events popping off as we make the video, perhaps. Let's bring this back to early in the day yesterday and let that play through once. By the way, it looks like we're going to get some better imagery here in the coming days because it looks like stereo A has turned a little bit more here. Moving out to the west of the Earth. That's a good thing. So there's stereo A. And here come Soho-Lascaux C2 and C3. These are the... We're going to move these forward also because these are showing very old data. So Soho-Lascaux C2 here on the left. You can see some CME action popping off around 3 o'clock and around 6 o'clock. They look like separate events, one out of the east and one out of the west, both likely to miss Earth. Soho-Lasco C3. That's my best guess. Let's take a look at our custom coronagraphs. So here's what we have. Now, it is showing the full data set there for the SDO. So we have SDO 193 angstroms there in the center. And so you can see two events happening there. Neither of them look like they are earthly directed. So there's one out of the east and one out of the west. We don't see halos from either of those. Let's get a little bit closer here to see if we see any plasma motions. So certainly we do see some motions from over here. I think it's two separate events. I think one will miss to the east and one will miss to the west. That is the best guess that I can give you as far as the available data. By the way, if either of those do happen to have an earthly directed component, it's going to be a minor CME impact there. Those are diffuse CMEs. They are not high speed or high density. If anything does arrive, it'll arrive sometime after midday on Friday, August 25th. So those are the facts. Let's take a closer look at 193 angstroms by itself. I'd attract your attention over there to the eastern limb especially. There is an event there on the western limb as well. If you've got other ideas as to what's going on, let us know in the comments. We do read all comments. And thanks to everybody who gets involved, wants to know more about things like space weather, astrophysics, heliophysics, etc. Next, looking at plasma filaments. And we sure do have a lot of plasma filaments, and they are quite dense and quite huge. So especially in the eastern limb and the western limb there, over on the right side of your picture, this one up here has been there for, it rose and it's been quite stable here. So that one is the biggest, densest filament currently on the Earth-facing portion of the solar disk. But there are also like 5 or 6 more down here in the southwest. So those could become coronal mass ejections. They could also collapse. They could even reposition themselves. That's been known to happen as well. And we've been naming filaments after living people, so there are quite a few names available there. If you want to name filaments after your friends, foes, neutrals, or even yourself, go join us over on Twitter. So there they are in grayscale, and you can see quite a lot of prominences there hanging off the solar disk, and you can expect that to increase in the next year, and then to still be at this level within about 2 years, because we're still like a year out from solar maximum. So these are facts. If those are controversial to you, by all means, leave an angry comment, say something derogatory, hurt my feelings. I'm very, very sensitive to comments on the internet. Pardon my sarcasm. Here's the past 24 hours. We've added 304 angstroms to the 193 angstroms wavelength to add some definition to all of those plasma filaments. So there's a great view of those. There's a great view of those. Tell your friends and foes about the Smash News Network, least busted name in news. We need your help to get the content onto screens. And one of the ways you can do that is by following us over on Twitter. So there's the Twitter feed. And let's just briefly put out my latest tweet. My latest tweet here on the YouTube channel. The latest tweet is the 7 Ps. Proper plausible physics prevents pathetic pseudoscience proliferation. You like that? Yeah, that's cheers. So hit us up over there. If you want to name filaments, follow the hashtag #NameThatFilament. And name your favorite solar filaments after your favorite, least favorite, or maybe even yourself, people. Living people, not dead ones. not fake ones. We're not going to be naming them Tom and Jerry or anything like that. And let's move on to the last about 2.5 hours here from the GOES 16 SUVI. Ionized helium, 304 angstroms. And check it out, we do have a solar polar vortex forming up here. So some plasma motions happening up there. That's always interesting. Those filaments we showed encircling the sun are now forming a plasma vortex. Oh my God, folks. It's time to be spooked. It's time to be spooked, folks. Get in your bunkers. A solar polar vortex has formed. And let's move on to our bonus feature segment. So let's blast through bonus features here, starting with satellite charging hazards. We have some minor ones here caused by low-energy electrons on the outside of spacecraft around Mexico and the eastern Pacific. Those are minor. They're not likely to cause any communications breakdowns. Here is the GOES electron flux over the past 3 days, and it is coming up off the floor here as the coronal hole high-speed stream subsides. No surprises there. And the ionosphere is going to return to a more normal state, not that it got that far out of normal in the first place. Here's the 1-year graph of the electron flux. Those are the relativistic electrons as measured by the GOES 16 and GOES 18 from their near geosynchronous orbits. They use radiography and they measure those electrons at the F layer of the ionosphere. Here's the forecast model by NOAA. The green boxes are the forecast and the yellow diamonds are the observation. Expecting an uptick there in the electron flux, and I would tend to agree with that. Now let's take a look at the layer where it's measured using radiography, the F layer. So this is the vibrational frequency of that layer of the atmosphere. The F layer located at about 300 kilometers of altitude. Here is the vibrational frequency in megahertz, millions of vibrations per second, as reported by the Australian Government Bureau of Meteorology. So this is the bridge between Earth and space. Let's just say there's not a lot of matter up there. It wouldn't be an appropriate place to go try to breathe. It is space, at least as pertaining to Earthlings, the F layer of the ionosphere. So that's the raw vibrational frequency. Here's the anomalogram, anomaly in megahertz from a 30-day median. We are seeing a bit of red there. That should be subsiding. Low-frequency anomalies depicted in red and high-frequency anomalies depicted in blue. Here's the latest image. That's 10:15 universal time for the ionogram and 10:15 universal time for the anomalygram. We also show total electron content. That's a completely different thing. It's the free electron count from 12,500 miles of altitude down to your GPS handset. Free electrons cause signal refraction, and here are the most likely places to see GPS errors. So quite a few errors here around the Southern Ocean and Antarctica. Some nighttime errors around the equator there. GPS errors are most common around the equator at noontime. And let's take a look at North America. We're just going to show the North American electron content anomaly. So here is that. This is going to show high electron counts in red and low electron counts in blue. It's the anomaly from the 10-day average. We are seeing some significant high electron content anomalies here over places like the Caribbean, Central America, the Leeward Islands, and before we get to meteorology, we will close out the daily space weather portion of this video with the latest high-res imagery of the closest star. So there is our SDO continuum. Here is our SDO magnetogram. And let's take a look at this new sunspot first. So not a good view of that yet, but it's actually a little larger than this sunspot to its north. And this sunspot now officially a beta gamma class sunspot group. So Definitely the most likely place to see large solar flares is on the eastern limb. Again, there is still a possibility to see them on the western limb, especially around here, and increasingly around here. So, but this is the real place to watch, and we'll be doing that. That's what's going on. And let's move to meteorology. So I discovered about 20 years ago that it's way too easy to forecast the weather, so I needed greater challenges in addition to pro bike racing. So there's that. I realized that forecasting the weather is way too easy, so I started doing space weather, and we include our meteorology segments here as a value-added service. So first of all, looking at Saharan dust, which is tamping down these low-pressure systems. These things had the capability of possibly turning into hurricanes or tropical storms, and I'm finding that increasingly unlikely. Even if they do, these three systems, 1, 2, 3, even if they do, and again, it's very unlikely that they do. Look at all the dust tamping down convection in those areas. There's also a lot of wind shear to their north once again. So you've got this upper level high right here. It is a clockwise rotating anticyclone, and that helps to break down the upper level portions of those. So the lower levels are broken down by dust, and the upper levels are broken down by wind shear. Those are not going to be very effective tropical systems. So that's what's going on for dust. And let's move to things like regular old wind. So here is the surface wind scenario for the eastern world. A strong low pressure here, south of Australia in the Southern Ocean there, kind of on the coast of Antarctica, the world's highest and driest continent. Here are the jet streams for this side of the world. Here are the jet streams for the west. We've got a huge anticyclone here over the central U.S. persisting there. That clockwise rotation, characteristic of high-pressure zones. It's likely clear skies over that portion of the U.S. Here are the surface winds of this side of the planet. Strong onshore wind there at Texas, as there is a strong low bringing massive rains. We'll show a flood forecast momentarily. First, the central world's surface winds and the central world's jet streams. Next, we'll take a look at pressure, and check it out, folks. It's very, very scary. In the northern Pacific, we've got 3 lows that are forming a triangle. And everybody knows that when it comes to meteorology and space weather and so on, a triangle is very spooky, which means it must be weather modification. Maybe it's HARP, maybe it's chemtrails, maybe it's solar radiation management or something. Pardon my sarcasm, folks, but there are 3 lows up there for real. And this low off the coast of Texas is indeed going to be a story. We'll get to it. There's the full world pressure map. That is mean sea level pressure. As we zoom in closer and closer to the lower 48, here's what's going on for clouds and fog over a still dark planet for most of that map. Shortwave radiation shows clouds and fog even at nighttime. So consult the NASA GOES Interactive Weather Satellite Suite for that, and let's consult the weather.gov map. So here's weather.gov, the National Weather Service homepage. And we still have some flooding in the forecast there. Also tropical storm warnings on the Texas coast. Excessive heat watches in portions of the U.S. If your location is lit, head to weather.gov and click your county or seaway and get your weather alerts. Here comes some forecasts. This is the GFS 72-hour total accumulated precipitation forecast in inches. And heavy rains there coming to Texas, like 3 inches. As far as the rest of the country, there are still some flood watches because drainage. However, that's the next 72 hours based on a GFS model. Here is the next 72 hours based on the GFS model for pressure and precipitation. And that low will make landfall and then break down promptly. So it'll cross Texas and then back into Mexico, where it will lose its low pressure status. Here's a 72-hour temperature anomaly forecast in degrees Celsius. Expecting temperatures 16 plus degrees Celsius above normal. That's a 72-hour GFS temperature anomaly forecast in Celsius degrees. We also like to show the jet stream, which is going to continue to stay mostly north of the U.S. here. The Pacific Northwest will see a little bit of jet stream. They'll get some warm air rolling in. But for the most part, the jet stream there staying in Canada. 72-hour 250 millibar wind speed forecast is what we're showing here. And let's take a look at the Atlantic. Here is the Atlantic pressure and precipitation forecast. You can see those lows are going to be kind of pulled up to the north. They're following the path of that wind shear, which is basically pulling them up to the north. And again, they're not being helped out by all of that Saharan dust. So, I mean, I said it like a week ago. This does not look like an appropriate situation for major storms to form in the Atlantic, and I rest my case. Facts. They're how you forecast things, folks. If you understand physics, you can forecast Earth weather, space weather, and maybe even beyond. So here's lightning maps. This is our NASA GOES lightning mapper. That's where lightning's been for the past about 10 hours. Let's see where lightning is upon making this video. Do we have terrestrial strikes in the U.S.? Well, let's find out. Barely. I don't think so. Oh, all right. Corpus Christi. There's some thunder rolling in Corpus Christi. And there is a lot of rain, indeed, rolling in. Those narrow inlets are going to be pretty full of water there, with 3 inches of rain and a powerful tropical low pressure system about to make landfall. So that's what's going on for real-time lightning. By the way, if you enjoy the content and you'd like to support the channel, consider becoming a member of the Smash team. There's a bronze level, which costs you $0 per month. We send out email alerts about videos just like this one because people complain constantly about not getting notifications from YouTube. So sign up for email alerts. It's free for most things. There's also a silver level, which gets you additional content, and a gold level, which gets you our plausible explanation for the solar sunspot cycles. You may want to look into that, the gold level. You can also get an @smashomash.com email address. So again, support us that way. It's similar to Patreon, just superior. We built our own website because Patreon lacks the capabilities that we have. You can also find links to all of our affiliates/sponsors and our social media. So follow us over on Twitter, etc. That's where most social media interaction goes on. And if you've unplugged entirely, we don't blame you. Today's featured product from the Amazon storefront is the coffee that I'm drinking right now, the Cameron's Scandinavian Blend. It is organic. If you think it looks expensive at $23.38, it's because it is a 4-pound bag. Yeah, that's a 4-pound bag, folks. It's actually kind of cheap. So save some money. Switch to organic coffee. Did you know that we stopped getting the jitters when we switched to organic coffee? Yeah, coffee. It's highly sprayed. So perhaps maybe switch to organic. Let us know if you have results for that. Amazon.com/shop/SmashOmash. Also the Hemp Lucid shop. Links below this video as well as on our homepage at SmashOmash.com. The most popular are the CBD tinctures. Also perhaps try out the mushroom gummies. I like the Stress and Focus gummies. There are also immune stacks there and all kinds of stress stacks and other products. Body balms now back in stock. Even CBD for your pets. Today's featured product is Since You're Sick, Stay Home. Or if you're sick, stay home. I'll just leave it at that. And I'm not wearing this one today. I'm actually wearing I'm wearing it's HIPAA, the Health Insurance Portability and Accountability Act of 1996. A lot of people seem to think it's evaporated since 2020. However, it still is in effect, which means your medical records are your own business. So don't be pressured. Don't believe nonsense. And if you're sick, stay home. Or perhaps since you're sick, stay home. Get yourself a souvenir, and congratulations on surviving a global pandemic so far. you're doing a fine job. Smashomash.com is the homepage. We built a massive web ring for people just like you. Mainly because of pathetic, putrid, and disgusting censorship on the internet. We are free speech purists. We don't mute people's comments. We don't ban people from commenting. We encourage all legal free speech. And of course, the hardest speech to support is speech you don't like. You can find a forum there if you want to post things like recipes, information about cosmology, geophysics, heliophysics, general science. There's even a free-for-all category at the forum. You want to read about our mission, you can find that at the forum as well. Smashomash.com/forum/mission. If you enjoy the content, do yourself a favor. Press the like button, press subscribe, press share. Leave a comment. Thanks to everybody who does and attempts to dope the algorithms. How's that working out? Oh, we're blowing up as a result of that, right? Oh, geez. I guess if you're already shadow banned and you leave a comment, I guess it's going to not really do anything because your comments are probably shadow banned. So I have no idea. It's truly ridiculous. So, and fun fact, our thumbnails contain more valid information than entire channels. So we'll close out here with Doppler radar, clouds and fog, and water vapor. So here's the Doppler radar map. It shows vertical motion in the air column. So that's radar.weather.gov, and we're focusing on the lower 48. Heavy rains there showing up at Texas. Here is the clouds and fog map. 3.9 micrometer infrared radiation, part of the NASA GOES interactive weather satellite suite. And here is water vapor, and you can see that clockwise rotating anticyclone there over the U.S. If you want to find the areas where people are going to think there are chemtrails happening, check out this area right here, because these transitional zones with pressure gradients are where you get jets of convective processes happening and differences in cloud nucleation and so forth. Pressure gradients are largely responsible for weird cloud formations, so look for those. People believing stuff about what's going on in the atmosphere because they don't understand atmospheric physics or aircraft tech. Chemtrails, not a thing. Still not a thing. Never were a thing. And if you think a persistent contrail is evidence of chemtrails, contrails have been persistent and well documented for over 100 years in the correct atmospheric conditions. A contrail tells you something about the atmosphere, not the plane's exhaust. Anyway, here is U.S. Doppler radar, once again, vertical motion in the air column. Here is clouds and fog, depicted by the NASA GOES interactive weather satellite suite shortwave radiation map. And last but not least, the water vapor map. When your Doppler is unclear, check out the water vapor map. It will clear things up. And hopefully I've cleared things up here at the Smash News Network, least busted name in news. Hopefully you don't believe a lot of nonsense on the internet. Remember, folks, proper plausible physics prevents the proliferation of pseudoscience. Anyway, we'll see you soon. In the meantime, I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.